Hello ladies, today we're going to be looking at our new unit, Introduction of Reasoning and Basic Proofs. So if you talk to any student who has had me for geometry, you will have heard, or if you know anyone who goes to another school, you will have heard of proofs. So in our class, we actually do spend a lot of time learning about proofs, how to write them, how to construct them, and they actually make you better math students because what they do is they actually force you to think about what you're actually doing. So like for instance, why is it that I can say these two segments are congruent to each other? And how it works is it's sort of like how you write a meal paragraph in Ms. Schuster's class. So you have evidence, you have analysis, and then you link it all together. So the main idea is sort of like what you're trying to prove. And you need to like piece together your evidence and your analysis to link it all together to construct a viable argument. So what we're going to be doing for the first day or so is we're going to be just looking at basic logic, so coming up with an answer based off a series of given information. So this is an edpuzzle lesson. There is no Delta Math assignment for this tonight. So your only assignment for me today is just to do this edpuzzle. Okay, so before we begin, we need to go over a little about what inductive and deductive reasoning is. Inductive reasoning is a method of drawing general fact based on specific examples and limited information. It involves seeing a pattern, and math is all about patterns and relationships. So like, it's math. Like, we like to look at patterns and relationships. We like to see what's going to happen next. We like to plug in things and then see what's going to happen when we plug them in. It's important because many scientific and mathematical discoveries came from conclusions made by using observing patterns. And when these patterns were being observed, they weren't actually 100% sure if they were actually going to work every single time. They just assumed it would, and eventually it did. A conjecture. You might not have heard this word, or you might have heard this word in maybe living environment last year. A conjecture is a sophisticated version of guessing based on known information or a pattern. So practice. What we're going to be doing right now is we're going to be using some inductive reasoning skills to make a conjecture. So in our first question where we want to come up with a conjecture is we want to determine the next picture in this pattern. So if I look, I have 1 dot, then I have 3 dots, then I have 1, 2, 3, 4, 5, 6. So when we're doing this, there's no 100% bulletproof way of how to approach this. So for instance, whenever I see this, I typically write down the number above. So if I have 1, 3, 1, 2, 3, 4, 5, 6. And I need to see what's happening. So if I look, I keep on adding, moving this up and adding below it. So if I look, I have 1, 2, 1, 3, 2, 1. So I think my next one is going to actually have 4 dots at my base. So 1, 2, 3, 4. And then I'm going to have my 3 above, 1, 2, 3. Then my 2 above, and then my 1. That's the next image of my pattern. And I'm just doing this by looking at the pattern that's happening before me. Okay, now in the next example, what is the next number in the sequence? So I have 6, 13, 20, 27. So I need to ask myself, okay, so how do I go from 6 to a 13? Or how do I multiply? Is there something going on? Well, let's look. To go from 6 to 13, you're going to add by 7. 13 to 20, you add by 7, and then 20 to 27, you keep on adding by 7. So I would think that if I wanted to determine the next number in the sequence, I would just add 7. So I do 27 plus 7, which will give me 34. That's the next number in my sequence. Now, here's this next one. Point C is between the endpoints of segment AB. So we actually want to make a conjecture about this. So here's the issue. If I do this and I say point C is between the endpoints of segment AB, I don't necessarily know where it is. I just know it's on line segment AB. So what I'm going to do is I'm going to draw a line segment AB. And I'm going to put C on it. I think C is right here. But here's the issue. I just texted Miss Daniel and gave her this information. And Miss Daniel told me that she put C here, which is correct because C is in between A and B. And my answer is also correct. Let's see what another teacher says. Oh, I just texted Miss Fiorinelli. Miss Fiorinelli just responded. Miss Fiorinelli told me to draw this. She put her C here. You know what? Miss McNally just called also. Miss McNally said this. Miss McNally put her C right here. So there are 4 different situations where our C is just like moved around, but it's still 100% correct in each case. So what we can say about this, if we wanted to, no, you would never have to make this conclusion yourself. This is just like sort of like, okay, like we're looking at a pattern. We can say that the whole segment AB is equal to our part plus part equals our whole. So I can say that line segment AB is equal to AC plus CB. And eventually you're going to learn that this is because of the addition postulate. Okay, now here's where inductive reasoning can sometimes lead to false conclusions. So when I say false conclusions is, before we were like, okay, so here's our pattern, but then boom, you could eventually change it. So inductive reasoning can sometimes lead to false conclusions. So in our first example, I have that all sheep I have seen are white. Therefore, all sheep must be white. Well, is that true? No, it's not true at all. This is 100% false. You could have a brown sheep. You could have a black sheep. So, no, not all sheep are white. And our next example. Again, here's where inductive reasoning leads to the false conclusions. On Monday, I kicked my cat and it scratched me. On Tuesday, I kicked my cat and it scratched me. Ladies, please remember, Mr. O'Sullivan is not a cat person whatsoever. So in this case, I don't condone animal violence whatsoever. But again, I don't like cats. Therefore, whenever I kick my cat, it will scratch me. Well, here's the thing. If you keep on kicking a cat, I think it'll really just like, take things to the next level and say, I'm not going to scratch you anymore. I might bite you. So the cat could bite you. And that's where I can make a different conclusion. So the cat could bite me instead of scratching. All right, let's go on to the next page. So deductive reasoning. So before we were doing inductive reasoning, where we were trying to look at patterns and based off information, now we're going to be looking at deductive reasoning. Deductive reasoning, the way deductive reasoning works is that you are given some information, well, a rule which is known to be true. So the rule is known to be true even if it might not be true. Then we use that rule to make a conclusion about a given situation. And the given situation is always extremely specific. So for instance, if I look at this example right here where it says that all students eat pizza, and I have that Claire is a student, I need to ask myself, what can I conclude? Well, I know all students eat pizza. Claire is a student, so what must Claire eat? Well, you guessed it, Claire must eat pizza. If I look at my next example, all athletes work out in the gym. Barry is an athlete. What do you think you can conclude about that? Well, I think I can conclude that Barry is an athlete that works out in the gym, so I can just say that Barry works out in the gym. Next example, a polygon with 3 sides is a triangle. PQR has 3 sides. Try to do this one by yourself. If you do this by yourself, you should get that I can say PQR is a triangle. Because it has three sides, and we just said that three sides is a triangle, so I can say PQR is a triangle. In our next example, we have people who like to sing join a choir. Sarah likes to sing. What do you think your conclusion is? Well, I think my conclusion is that Sarah will join or has joined the choir. Now, here's what we're eventually going to be doing. So, you're going to be seeing this often. Before we go into it, let's just go over a little detail or two. In the following example, you are given information. You must interpret what this means by marking the diagram and then writing it in your proof. Write the definition or theorem that justifies your conclusion. Okay, so given C is the midpoint of AB. C is the midpoint of AB. So, I can conclude a bunch of things right now. You're not only going to be given information when you do real proofs. Eventually, you're going to be given this. Prove. But we don't know what we're proving. We just want to see what conclusions we can make up. So I have in here that C is the midpoint of AB. So if I look at my segment, I have C right here, and I'm telling you right now that it is a midpoint. Well, you need to know what a midpoint is. So if you look at some of our notes from the beginning of the year, you will see what a midpoint is. So here's what we do in this proof writing process. We have tables that we're going to put together, or charts, or T-charts, that are going to say statements and reasons. Every statement you write needs to have a reason. Like, you need to tell me why you're saying what you're saying, and you need to make it a real reason. So right now, I have C as the midpoint of AB. Well, I know that a midpoint creates two congruent segments, so I can say that AC is congruent to CB. So I'm going to put that as a statement. Statements are what you say. So I'm going to say AC congruent to CB. And my reasoning is a midpoint creates two congruent segments. What some students have written over the past 2 years that's also 100% acceptable is a midpoint creates two equal halves or two congruent halves. As long as you have something along the lines of a midpoint creating some two congruent whatever or two congruent pieces, that's 100% correct in my book. So your statements are the conclusions you're making, and the reasons are basically your evidence or your thoughts about it. All right. So now, where do these rules come from in geometry? These rules come from that we're going to be looking at over the next few months, because we're going to do at least 2 whole proofs units, and then in our future units we're going to have at least a day or two of proofs in each one, and algebra. So where do these rules come from? These rules come from our theorems, our corollaries, and our postulates. Theorems are statements that are demonstrated to be true by accepted mathematical operations and arguments. Corollaries are statements that follow readily from a previously proven theorem. And postulates are a statement to be accepted to be true without proof. So for instance, addition, subtraction, those are postulates because we just accept them to be true. We accept 3 plus 3 to be 6. We accept 4 plus 12 to be 16 and so forth. And those are where our rules are coming from. So you're going to be seeing a lot of stuff we've done over the past few units pop up this unit and the next unit, especially when we try to look at triangle proofs where we prove that triangles are congruent to each other in a variety of situations. Okay, that's it for today. If you have any questions, please email myself or Miss Daniel. And as I said before, there is no Delta Math. There's not going to be a Delta Math tomorrow either. Oh, wait, no, there actually probably will be. My apologies. But yeah, if you have any questions, email myself, Miss Daniel. Miss Daniel has extra help on Monday, Wednesday, and Friday during second period. Have a great day, ladies.